Hi everybody, I'm Tanishqa from group number 8, and today we'll be talking about project scheduling techniques and tools. So before we begin into the topic for today, I'll give a brief introduction about our group. I'm Tanishqa, and after me it'll be Wenchao presenting, and then we'll have Vathsauv and Tahmid in this particular order. So our first topic for today will be on dependencies. But before we understand dependencies, it is essential to understand the concept of work breakdown structure. So work breakdown structure is basically when we break down a particular project into multiple tasks or activities. For example, if we have a project of building a website, so that can be broken down further into multiple smaller tasks, which can be like front-end development, back-end development, UI designing, user experience, and finally testing and deployment. So we have broken it down into these six, seven further activities. So that is where our top is the project that is built from top to bottom. Is our top is our project and bottom are these multiple activities. These are the lists of tasks that have to be completed in order for the final task to be completed. So this is basically essential to understand what dependencies are. And another concept is of project scheduling. So basically, once we have these tasks with us, it is only these tasks that we have. It is not the sequence in which we're going to do. So project scheduling helps us understand that exactly the timeline or when, on what order the tasks have to be completed. So after the tasks that are defined, we sequence these tasks. That is the order of these tasks, which is going to be done before or after which task. And it is essential basically to understand a brief idea about the timeline and a rough estimate about how long the project is going to take or the amount of resources that we're going to require. So dependencies basically is in the previous example, for instance, if we have to complete the task of say, testing a particular piece of code that is dependent on the development part of it being completed. So here the one activity is dependent on the other. So it shows how these tasks rely on the other previous tasks. So basically essential to understand the relationship between these activities, and that is needed in the project scheduling that we discussed. So these tasks can be scheduled according to how many tasks are dependent on which particular tasks or which has to be completed in order for the next task to be done. It is also necessary for us to understand dependencies to determine the critical path. Critical path we'll be discussing further in the presentation. Another thing is of precedence relationship, which is nothing but if we have, say, two tasks, the one which is done later is the successor, the one which is done earlier or before that is the predecessor. So if it's a finish to start activity, the predecessor has to be completed, so the next one can be started, that is the successor. So similarly, that is what start to finish is the predecessor has to begin for the next one to be completed, finished. So similarly, the start to start and finish to finish activity. So it's a type of relationship. Now, why exactly are we trying to understand dependencies is basically so that we are able to plan a project better. So if we know which particular task is highly dependent, we are trying to complete that task so that the other activities or tasks can also be done. It is also essential to understand the coordination. I mean, other teams in the particular, other people in the project are able to understand which is supposed to be done when. So it is kind of improving the coordination among them. So next will be of critical path, which Wansha will be taking over. Thank you.
Thanks, Kanishka. My name is Wenchao Shen. My student ID is 300683420. Today, I'm going to talk about critical paths. The critical paths can be observed in the project management, especially within project diagram or Gantt chart. Today, this presentation will divide into three parts. First, I will give a definition about what is critical path. Then I will explain why it is important. And finally, I will illustrate how to calculate the critical path briefly. Okay, let's moving on to the first page. The definition, what is critical path? The critical path can be defined as a series of activities through the whole network schedule that has no slack or float. And in an IT project can have more than one critical path. And also the critical path will be the longest path through the whole entire network. Maybe you will have the problem about why the critical path is important. So let's move on to the next page. Because the critical path, there's no any slack. So any delay in one of the activities will put off the entire project. So it means it represents the greatest risk of activities to the whole project. So during the project, we should keep in mind, keep our eyes on it and find it out first. So next page, let's move on to the next page. This slide shows it's a how to calculate the critical path by activity on node diagram. So let's look at the left side of the diagram. The essential information for the diagram including activity ID, duration, and we can use early start time plus duration to take the early finish time. And take a verse, we can use late finish time minus duration time to find the late start time. And we can subtracting early start time from late start time to calculate the float of the activity. So once we understand all the activity on node diagram, we can extend to the whole entire schedule. Let's look back on the right side. It's an entire schedule, so we should list in the entire networking schedule, figure out all the activity ID, and estimate all the duration and take the sequence, and then we can start to calculate. We start from the right to left, take a forward path to calculate all the early dates, and then we take a turn from left to right to take a backward path to calculate all the late dates, and we subtracting all the early starts from the late starts, so we calculate out all the floats, and then we just point out all the zero float activity and linking them together. That's the critical path. So overall, all the content above, that's my presentation, and I will put more details in my individual presentation reports. Next, let's welcome the next my group buddy Vathsauv to take next part. Thank you.
Hi guys, this is Vathsauv. So today I'm talking about schedule compression and buffers. So buffers are nothing but they are used to protect the project schedules from uncertainty and delays. So usually companies will be using these buffers whenever there are any delays or things which are not going in that way. So they can use these buffers and get the thing done and submit the project within the deadline. So usually there are three types of buffers. One is like project buffer, and second one is like feeding buffers, and the third one is like resources buffer. So project buffer is nothing but a buffer. These buffers usually placed in the end of the project so that if there are any delays which need to be submitted or completed before submitting the project, they can use this buffer period because of the uncertainties occurred in the team itself. So they can use this and complete the time within the deadline. And the feeding buffers are used when they are merging, when there is a merging thing going on between the non-critical chains and critical chains. These will be used as the shock absorber so that the critical chain, the main critical chain won't be delayed, and it can be submitted and done in time frame which was agreed to. So, and the last one is like resource buffer. Resource buffer is nothing but these are used and placed before they're agreeing to start the task, because they need all the additional resources to be given for them before starting the task. So to complete that task, they need that buffering period to get the resources. So usually they can also use the total float and free float as well, so that there won't be any delays in the next task are affecting the overall project. So if they use these two, they can just complete it within the time frame. So schedule compression. Schedule compression is nothing but compressing the schedule of a project and agreeing to do the project within less time, but not but there won't be any change in a scope. So in scheduling compression, there are like three types. One is like crashing, then the other one is like fast tracking, and last one is like do less. So in crashing, they will be using like adding the additional resources to the project and get the things done faster, but it costs more. So in fast tracking, they will be doing the same tasks, like different tasks at the same time, and there will be a risk as well in this. And do less will be if you do like if we use the do less technique, there will be a chance of quality compromise as well. So yeah, there are like different tools of IT as well. Whenever like we are doing a project scheduling, there are tools which will be used in every project, and Gantt chart is the most important one used in uh, all the projects and also in the IT projects as well. However, in the IT projects, there are like velocity charts and burn down charts as well. So they will be using these more because they have those sprinting inbuilt over there, and to track the progress and also the team success as well. So also, it is better to use the change control documentation after every step of modification so that there won't be any issues and also the project won't be seeing any scope creep. So yeah, that's it.
Hello everyone, I'm Abdullah Rafi. My student ID is 300689816. Now I will talk about project scheduling challenges and resource constraints in IT projects. Whenever we are looking at a schedule on paper, it seems very feasible. But in real life, whenever we are dealing with IT projects, we have to deal with different kinds of constraints. Like you may have a plan, you have decided the deadline, but in reality, you may not have the right people at the right time. IT peoples often deal with specialist trap because IT projects deal with specialist stuffs. For example, you may need development of ops engineer, security, cyber security expert, or any kind of technical staff that may have to deal with two different projects at the same time, but they may not be available at the right time. As a result, you have to let the process go, and and it may create the deadline in danger. For example, in case of any banking app project, may the team decided like they will complete the entire project within that 1 week, along with the security checking and everything, but the technical stuff that is required for doing all this process may not be available. As a result, one task has to wait, and that creates the delay. In that scenario, project manager's dilemma will have to be deal with different kinds of choices, and each choice does come with specific cost and its relevant ripple impact. It will not only can create the spending, but also create pressure on existing staff, and may have impact on quality. There is another problem or challenges project manager has to deal with, that is lack of right skills. It's not always the scenario like right skills are available in a project. So to deal with that kind of scenario, we can focus on a practical aspect of Microsoft. Microsoft has recently introduced AI supported code review to deal with deal with bottlenecks. It not only help them to streamline the process and achieve the deadlines, but also it removed the dependency on specific set of people. And in case of Atlassian, it is highlighting capacity planning, because it gives them the perspective from down to top management view. So what can be the strategies for success? Like we have to use detailed task level estimates rather than guessing from top down. We can use different project management tools like Gantt chart and Kanban to improve visibility, and communication plan can be implemented from centralized hubs because it will help to prevent missed deadlines. And in case of developing a scope management strategy, we can define, monitor, and strictly control to ensure the project boundary. That's all from Group 8. Thank you, everyone.